Hello YouTubers, welcome to part 8 of making bow and arrow series. In this video, we will set up the world and start to test out what happens with our controller. So let's see the table of content for much clear understanding. So first, we will create our world using different CSG boxes and try to make our hit objects, and also we'll try to create some lasers for our player's reaction. So prerequisite for this video are basic understanding of CSG boxes in Godot. Alright, so now let's see previous recap. In the last video, we created a arrow system, set up shooting arrows, aligned it with bow and fixed rotations and some physics issues. And if you did not watch the previous video, then please go ahead and watch it before going further. Now we will be making the world for our player, and the environment will be something like this. So we'll have some walls around, and these will be obstacles that will hit our player, and we will add hit reaction on our player in the next tutorial, but we'll just create our world now. So this will be the hit reactors, and this will be the targets that our player will hit, and we have a slope kind of leveled up stage so that our player can test the fall animations that we created. And also we will have these idle kind of targets that our player can hit, and these targets will be moving in left or right direction, so the player can also target and try to hit these stuff while it's moving. So this will be the environment that we'll be creating now. So for this environment, so we'll be using 3 textures here, and the link of these textures is provided on my description. You can go just check out the website and you can just freely download these textures that I have created myself. So once you download these textures, you can just copy them and go to your root directory, and here let's create a new folder. So Ctrl Shift N to create a new folder, and let's rename this as maybe textures, and here let's paste those 3 textures. So we have this white ground and this target. So now let's jump back to Godot, and here in this world we will be creating the world environment here. So let's delete this CSG box and let's go to top view. Let's make the ground bit more larger, and let's also organize our level. So let's add a node 3D and let's rename it to be environment, and let's drag and drop our CSG box under the env node. Now we can try to add the material for our CSG. So in the geometry, let's add a new standard material. In the albedo, let's open up the texture, and we can add this ground texture. So now you can see that the texture is very large, so we need to scale it down. In the UV section, you can just play with the one of the value, and X, Y and Z all together are being scaled. So let's see how much we need to scale. I think we can scale it to 25. Okay, and now let's add the 4 wall corners for this scene. So we can duplicate the same stuff, rotate it, and let's scale it down on the Y axis. Let's place it roughly at this point, and now we will do the same stuff. We'll select our newly created wall, Ctrl D to duplicate, and let's paste the other side. And by the way, for this panning, just click a right mouse button to pan around the top view, and to zoom the mouse wheel, and let's place it here. Let's now select both of these, Ctrl D to duplicate, and let's rotate them. Okay, so I think we need to scale this properly. Let's duplicate it, position it on the other side. Okay, so the scaling is not properly just because the textures are now not properly applied. So let's properly fix it now. And you can see that changing the scale is also affecting our ground. So how do we fix that? Well, we need to change the scale of this without actually affecting the ground. So for that, we can just select our ground, and here in the material section, just click this icon and click on make unique. So now we can try to change the UV, and no, this ground UVs are not affected. And similarly you can do with the other two of these walls. So this and this are not similar to these and these walls, so we will change the scaling of this wall first. This is fine, I guess. It's not meant to be exact same, but almost similar is fine. And we need to scale this y-axis, so let's click this unlock component ratio, and now we can change it to be 5, and the z value is completely optional because we'll not be seeing it from the top view. So the z value is just ignored. Anyways, now you can also change these offset position. Okay, and these both walls are looking fine. So now let's add the slope area. So to add the slope area, let's add a CSG box, and now we need to assign the material, but we'll assign the material later on. First, let's create the proper shape of our slope. Let's place it here. You can just press Shift F to go in the first person view that I have told previously. And let's press Ctrl D, duplicate this same slope again. Okay, so once it's properly placed, now we can also set the collisions. So let's enable use collision, and we can set the collision layer to be in the world. We can just uncheck the collision mask for both of these boxes, and let's also assign the material. Let's assign the texture, and the texture this time will be this white, so we'll assign the white texture rather than the ground, and we need to scale it up. So in the UV section, let's scale it up, or before that, make sure this lock is turned on. Okay, so now the slope is finished, and let's add this slope to a single box. So let's add a CSG combiner. Let's just drag and drop both of these inside the CSG combiner, and it's better to use a collision on the CSG combiner rather than both of these. So now we can easily move our slope without being, changing both of these values. Cool. Let's also rename it to be slope. And the last thing is to add the hit targets. So for that, let's add a node 3D, call it as target, and here let's move our character somewhere else, and in the target let's add a mesh instance, and I think we can just scale it somewhat up to see our mesh. And in the mesh instance, let's add a cylindrical mesh, and here in the mesh we can just change the segments to be 8, or let's make it as 12, and let's also change the height to be somewhat lower. And now in the geometry section we can add a new material, and in the albedo let's drag and drop the texture, and you can see that the texture is not properly set with our mesh, so we need to change the UVs, also the offset. Okay, so the offset is 0 is fine, and the scale let it be 2. And if your object is out of focus, so in my case I want to focus on the mesh object, so you can just double click on this mesh to have the focus on that. And now we can rotate it slightly, and let's also add a mesh instance, and this will be the direct child of this target. So this is our hit, not git, and this will be the stand. I don't know what to call, but stand is fine. And now let's add a box, and let's make the rotation 0, and let's also scale the box so that it's kind of stand for our target. And I think we can just make it long. I think we can make it still more longer, and let's place it here. Let's also make it slightly thinner. Cool. Now we need to make this target to react with the arrows. So for that, I think we can change it to be a type of static body, so that static body can react with rigid bodies. So you can add a area 3D or a static or a rigid body, but static body means it doesn't move whenever any other objects try to hit. So let's also add a collision shape for our static body, and I think we can try to create a collision shape using this mesh instance. So in the mesh, let's create a collision shape. The type will be, let it be sibling, and simplified convex. Now this will act as collision shape that will detect the arrows. Okay, and we can set the collision layer of this to be in the layer of object, because this is an object that will be interacting with the arrows, and the mask is optional. And let's also save this object as a separate scene, because we'll be using this scene a lot more times to decorate our environment. So let's save branch as a scene, and it will be in way to keep it, or let's create a new folder, call it as scene, and this will be the target scene. Let's click on save. Let's place it somewhere here, and now Let's also duplicate it 2 more times. And now we need to check our arrow if it's colliding with the environment or the target. So let's try to hit. And where is our arrow? Well, it doesn't actually hit these targets. And why is that? Well, that's because the arrow's collision shape, I mean the arrow is not interacting with anything, and also the collision shape is useless because it doesn't interact with anything, and the collision is no more valuable for us. But in the code, I have written this set collision mask and also to exclude self. So now it's time to explain what this exactly means. And this means that we are setting our arrow to interact with the word. So this one less than 3 means we are setting up this collision mask to word. So if you remember the diagram, then if there is no collision with any of the object and if the arrow is moving on and it hits an object, so that's basically word. So we need to detect the hit of the arrow on the word. So whenever we try to create a raycast and check if there is any interaction object in between those two frames, we also need to make sure that our arrow can hit on a wall. So that's the reason we set its collision mask to the layer 4 using this. And also we exclude the arrow itself, so it doesn't detect hits on itself because in the arrow we have this collision shape. Cool. Now how do we make the arrow to hit the target objects that we have just created? Well, for that we can add a area 3D node with a collision shape on it. And now you may ask like, hey, why do we need to create an area 3D node when we have this rigid body that can detect collisions? And the answer is like, the rigid body may sometimes hit our target and it may bounce back for that hit, and when it bounces back, the arrow cannot register a fire on the target. So the area 3D node helps us to detect our target whenever the arrow tries to move through our target. And if you don't get what I mean, please go ahead and check out my video on collision and layers so that you have more better understanding. So now let's delete this collision shape. Let's duplicate our collision shape created for the arrow and let's add it as a child of area 3D. And now the area 3D in the collisions, we will assign the layer in our bullet and it can interact with the objects only. And for it to interact with the word, we are setting it over here. So the area will only interact with the objects, it will not interact with any other thing. And for the word to interact, we are using this collision mask inside our query. Cool. Now whenever our area tries to interact with any of the body, we can connect a signal from here. So select the area, on body entered, we connect it to the root node, and here if the body it has entered is present in a group, let's rename the group as target. At that time what we can do is we can delete the target and also we can delete the arrow itself, and let's just call the self.query to delete the arrow itself. So now what does this line mean? Well, if our area detects any object and that's in the group target, so let's open up our target and we can assign it in the group. Let's add a group, call it as target. So make sure this spell is same as this one and let's make it global and let's turn on this. So now this hit is in the group of target, so we can check if the body our area has entered is in the group of target, which means that the body our arrow has entered is our this mesh. So at that time we can just delete the body by just calling body.query, and we also delete our arrow itself so that it does not register multiple hits. Cool. Now let's check out if everything works. Let's also clear out the rotation of our player so it's facing forward direction, and also we can slow down the speed temporary. Let's say it as 60, and let's check it out now. And you can see that our arrow is actually hitting the ground, and the offset value of 0.7 is actually working. Okay, now let's try to hit these targets, and we get an issue that our player does not exit our aim state. So we'll fix that. Now, how to fix that? Well, for that, let's see if the problem is with the animation tree. So let's see the edit filters. Either it's here, and yes, let's turn on these functions. Let's try it now. So after banging my head a lot of time to get the problem, what was the main reason that was causing this problem? Well, the main reason was that we duplicated this collision shape from this node, and we just disabled this node. So this collision was not actually working, and the same thing happened with our duplicated node. So even this node got this disabled option to be turned on. So that's the reason our arrow was not detecting these targets. And also I just figured out one more issue, and that was the player's movement was not natural. Like, it was feeling that whenever player goes to active state, he was slipping on the floor rather than walking. So to fix that, I just found out that here in the move function, so this is the function that we call from this active aim states, and here we just hard coded this value 3. So we don't need to hard code these values, but rather we need to assign it with this variable speed. So let's change this function a little. So initially the root motion position we get properly, but then the horizontal value is equal to our transform basis, and we remove these lines, so it's just the multiple of transform basis with our root motion. And then we need to set our horizontal value to our physics process, not the process. And then we need to multiply it with our speed value, and we can just erase this. So it's basically this division and multiplication are done in two different steps. And also I think we can just reduce this speed value to 3, so that it feels kind of natural. And now let's test it out. So let's try to move, let's go to active, let's try to move, and okay, this feels way more natural than what we had previously. And also let's try to shoot our arrow, and this time, yes, the targets are actually becoming invisible. And we also need a crosshair at the center so we can know where exactly our player is shooting the arrows, and rest everything is working fine. Cool. So the next part we left is with our hit target. So here we actually need our target to move left or right, based on some conditions inside our word. So for that, let's attach a script for our target, and let's create a folder for that inside our scenes, and let's create the script. So here So now let's see what exactly this script means. Well, this upper limit and lower limit are basically for the the maximum distance our node can move towards left or right, and we can easily set those limits for each of the node at this point. So each of the node will have the random movement and also the random distance to travel. So using this export var really helps us to set different kinds of datas for just a single node without having creating duplicate nodes and without creating duplicate copies. All right, so next we have this time. So how fast we want it to move from left to the right limit. So the time will determine how fast our object to move from this point to the next point. And maybe a slight confusion on the naming conventions, but the two upper means that whether it should move to the upper limit, and also the move node will determine if we want this node to be static at a single point or we want our nodes to be keep moving. And then we have a variable tween and a moving left to true, which means whether we want to move to left or move to right. Okay, and now if the upper limit, that means we need to move towards right, so we set our moving left to false. And if we have our move node, which means that we don't want our node to be static, then we call this move function. Well, this function both are interconnected to each other, so this function will help us to move our node from one point to another point, and as soon as it moves to the next point, we again call the same function at a different direction. So this time the direction will be changed using the not. So if it was moving to right, let's say, then once the function finishes, it starts moving to the left. So this is how it works. And let's see what is inside this function. So this basically determines which direction we want to move. We create a tween so that there is a gradual movement of our node, and once it finishes, we just call this again, so it turns to another direction. And here we also created this function called hit. So in this function we just delete our node from the scene. So now in the arrow, if you have seen at the bottom section, we just call the body.queueFree to delete the node, but I don't think this is a proper way to delete a node, so we call the hit from the target itself so that it can delete from the scene. Cool. So now let's save the scene, and also let's make one more scene for our laser. So this time let's add a node 3D and let's rename them to be laser. So all the laser will come under this section. And now let's add a CSG box, and inside the box, we can just scale this box up, maybe in one of the axis. So let's scale it in Z axis. Let's make it slightly thinner. Okay, now let's place it somewhere over here. Let's duplicate it few more times, or before that let there be a single laser, and we can just save a branch from the scene, and let's save it inside the scenes folder, and let's name it as laser. So this will be useful to play the react animation on our player. And let's open the scene and let's attach a script for it. We'll store the script inside the same folder where we stored our target.gd file. And now let's create this. So again, here we will copy the same script from here, so the target script that we had, and let's paste here. So this is again the same script that we had in our target, and we will just slightly change some of the values. But before that, let me just quickly again give a reference of these variables. So we have this upper limit and lower limit that will determine the movement of up and down for the laser, and then we have the time that will determine like how fast we need to travel from one point to different point, and then we have this to upper that will say whether we want to move our laser upward or downward. Then we have this move node, and yes, we can delete this. Okay, so we always want to move our laser. It's not something like that we had in our hit target. Cool. Now we just create the same move function to move our laser to one target, and after it finishes moving on that target, we just change the target value to another direction, and then we just call the same move function. And here we don't want this hit function. So now how will this laser react with our player? So for that we need to actually add a area 3D and a collision shape that can determine whether a player has entered our laser or not. So let's assign a shape of box for our laser, and let's roughly place the box outer area to match our laser. Okay, and we can also give a color for our laser. So let's quickly give a red color. Okay, this looks cool, and now the area will be detecting if our player has entered this laser or not. So maybe like we'll keep the laser moving here, so it will be moving up and down. So whenever our player comes in contact with the area, we can make our player to play the hit reaction along with some health damage if we have some health. So for that, let's go to our node. In the signals, we can select this body entered signal, and we can connect it to our CSG box. So whenever any of the body enters our laser, it will trigger this function. So in this function, if the body is in group of player, and just remember that this laser part is not yet implemented on our player. So if you are just worrying like, hey, what this guy is doing, then just have patience, because this laser was a concept of the word, so I don't want to go again and again on this creation of the word. So that's why this laser part is created before actually implementing the reaction part of our player. So now if the body is in group of players, so we'll be adding our player in a group, and let's make it global. So now our player is in a group called player, and the hitboxes are of this collision shape. So whenever this player's collision shape enters our laser, then it triggers this function. So whenever it triggers this function, we can just for now have a print statement, and let's name it as hit the player. Okay, and now let's decorate our word. So let's duplicate it to a few more times, and we can also rotate our laser. We can roughly place them up and down. Okay, and let's set these values in our inspector for each of our node. So let's call the upper limit to be let's say let it be 5, or let the upper limit be 0 for this, the lower limit let it be 5, so that this goes downward, and the time it should take to go down is 5 seconds. And should it move towards up? No. And let's do the same thing for all of our other lasers. So this should move 3 digits up, 2 digits lower. The time it takes will be 7 seconds, and it should move towards upper. This node should move 6 digits lower. Should it have upper limit? Okay. The time it should take is 7. Should it move towards up? No. And then we have this last node, not last, the second last. The upper limit, let it be 5. The lower limit is no, 0. And the time it should take is 8 seconds. Should it move towards upper? And yes. The last node, the lower limit 5. Time it should take is 6 seconds, and it should not move towards up. Cool. And I think, like, hey, for the script there is some problem with the target positions, and that's what we are setting the x values, but this should move up and down. Anyways, we'll just figure it out what direction we need our lasers to move. And let's first set our these arrow targets, placing here. Let's also rotate them, and let's create a node 3D, call it as close target, and let us drag and drop our target inside our close target, so that now we can duplicate our targets couple of times. These are just some simple decorations and don't make like this. So these are just for attracting YouTubers. Okay, and now let's select all of the nodes by selecting the edge node, and then shift and then select all the nodes. And here, should we move our node, and we don't want it to move the node, so make sure this checkbox is disabled for all of the nodes. And also, similar to our close target, we can add one more node 3D, and this will be our moving targets. And let's drag and drop one of the target inside our moving target, and let's place it here. Let's duplicate it a few more times. Okay, and now we can set the upper limit, lower limit of each of the targets. So the upper limit, let it be 0, the lower limit let's say 7. So all these are some random values. Make sure this move node is turned on for all of this. Okay, so once it's finished, we can create those same areas at this point. So again, let's add a node 3D, and please don't say that I'm just spamming up node 3ds everywhere. And let's call it as close target 1, and this time let's move this third target inside the close target. And now why do we place these targets here? Well, that's because we don't want our player to move on this slope hill. So it will block our player to move on this slope and unlock the fall to land animations. So player will only pass through this slope and he will only fall once he clears these targets. Anyways, let's test our scene and check if anything is broken. Okay, these nodes are moving perfect. What's wrong with this? It's not moving, and also these nodes are moving and these lasers are moving sideways rather than moving up and down. What about this? Okay, let's check our fall to land. Cool. Let's also check. Yes, it's working. Let's check the active fall. Cool, it's working. So we need to change these lasers to move up and down rather than horizontal. So these lasers are moving in this direction, so X, and we don't want it to move in X, we want it to move in Y direction. So let's select any of the laser, and instead of the X we pass our target value in Y, and the X position will be same. So now let's check it out. These are moving but they are way slow, so let's change the duration of this to be way faster. And now they are properly working. Cool. And even the movement is proper. Okay, now it's time to see all the scripts that we have made. So that's it for this part. Let's see what all we covered in this video. So we created a basic world for our player and made some hit and laser objects, and also we tried to create some interactions with the object and placed everything on the scene. Alright, before we wrap up, if you enjoyed this video, then don't forget to hit like, drop a comment, and also subscribe for more future content. And if you'd like to go with an extra mile in supporting me, then you can just grab the potato card membership on my itch.io for just 1 USD. Every bit of this support really helps me for keep me creating more stuff and improving for you guys. Thanks for watching, and I'll see you in the next one.